Hello everyone, this is the tutorial on public transit microsimulation using VISSIM. In this tutorial, we will create a corridor by extending one leg of the intersection. Then we will add transit routes, transit frequency, bus stops, and passenger boarding and alighting, and then we will run the simulation. After that, we will add an alternate scenario, which is a queue jump lane. We will add a queue jump lane in our intersection and compare the LOS and average vehicle delay for the two scenarios. So let's get started. We will open the previous file that we have created in the first tutorial. So go to the directory and open your VISSIM file that we have created in the first tutorial. So this is our Gordon intersection. Now we will extend one leg so that it creates a corridor or looks like a corridor. So extend one link and adjust the shape of the link with the background. Control right click to generate intermediate points in the link and then adjust the points according to the background. So now our corridor has been created with extended links. Now we will place the bus stops. So to place the bus stops, we will go to Google Maps and locate Gordon intersection, Springfield at Gordon intersection. From the Google Maps, we will take the measurement of the bus stops, the location of the bus stops. So here is the Gordon intersection. If we zoom in, we can see the bus stops near the intersection. This is a Springfield at Gordon number 8 bus stop. We will measure the distance from the intersection to that bus stop, which is 22.26 meters. Now we will measure the distance from our intersection and place the bus stop at the distance of 22.26 meters from the intersection. So for this, first choose the public transport stops from the network objects and then use the measure tool in the upper toolbar to measure the distance from the intersection. So we will take the measurement around 22 and then place a bus stop in the link. So right click and add new public transport bus stop. A dialog box will create and press OK so that everything is set as by default. Now we have to move the bus stop to the right place. And from the map we can see this is not a stop bay, so it is on the road. Now we will measure the another bus stop, which is westbound. We will check the measurement from the Google Map, and with the measuring tool in VISSIM we will place another bus stop at that point. Now we have another bus stop which goes eastbound. So we will measure the distance from the intersection of that bus stop. So as you can see, the distance is from the stop line of that intersection. So we will take around 248 meter approximate distance of the bus stop from the stop line. So right click and add new public transport stops. So our 3 bus stops have been created. There are other bus stops on the left side, right side, but you can do it by yourself by measuring the distance. So here I am showing this bus stop is on the road, so this is not a stop bay. But this bus stop I will create it as a lay-by stop for learning purposes. Now we will add platform edge. So right click and select add platform edge at right. Now press Ctrl and select the platform edge and drag and create a duplicate of that platform edge. And this platform edge will be used as a waiting area. So select waiting area from right click of public transport and elevators. And boarding allocation is a front, and waiting behavior is wait if held up. and everything stays as default and press OK. So this is our lay-by stop. Now we will add platform edge to this bus stop and create a duplicate of the platform edge by pressing Ctrl and dragging. We will also create this as a waiting area and boarding location is front. The waiting behavior is wait if held up and press OK. Similarly, we will add the platform edge and waiting area for this bus stop also. Now that we have created all the bus stops and platform edge, now we will create the public transport lines. So go to public transport lines in network objects, select it, and then right click on the desired link and select add new public transport line. So a green bar will appear and drag it to your desired location. So vehicle type is bus and your desired speed is 50 km/h. For departure lines, we right click and generate start times. So begin at 100 seconds and the rate is we will create every 150 seconds. And it will end at 3600 seconds. The occupancy per vehicle we will choose 15% per vehicle. Press OK and press OK. So we have added the public transport lines. Now to make the transit move to the lay-by stop, so press Ctrl and right click on the route and drag it to the lay-by stop. You have to double click on the stop. You will PT line stop dialog box will generate. Select active and alighting location is front and rear. Alighting possible, we will uncheck the left boxes and press OK. We will add public transport lines to the other direction similarly. So we will adjust the desired speed as 50 km/h and the departure time, right click, generate start times, begin at 100 seconds and rate is 150, everything is as before and press OK. Double click on the bus stop to see if it's active or not. If it's unchecked, you have to check it. Alighting location is front and rear and we will uncheck the left side of alighting possible. Press OK. Now to see the lists of public transit lines, right click and show list of public transport lines. So you can see there are 2 lines have been created, or routes has been created for transit. This bus stop is inactive, we have to make it active. And everything is fine. So you can see one is to eastbound direction and the other is towards westbound direction. Now to input the alighting passenger, we have to create the pedestrian areas. So select areas from network object and rectangle areas. Now press Ctrl key and right click in your mouse and drag and create the rectangle area. Once you create it, a dialog box will appear. In this dialog box, the usage is none since it is not for waiting area or platform. So it will be kept none and press OK. Similarly, we will create the other pedestrian areas on the other two bus stops. So Control and right click and drag your rectangle. You have to make sure that the pedestrian areas are overlapped, that they are not detached from each other. Some portion of it should overlap each other to create so that a pedestrian routes can be created. Now we will input the pedestrian. So select pedestrian input, right click on the area and add your pedestrian volume. So here we will add pedestrian volume here as 30. Similarly, add pedestrian input for other pedestrian areas. So Control right click will add a pedestrian input for your areas. You can also do it by right clicking and selecting that pedestrian input. Now we will add the pedestrian routes. So select pedestrian routes from the network objects. We will create two kinds of pedestrian routes. One is from the pedestrian areas to the waiting area, and another one is from platform edge to the pedestrian area. So one is for boarding passenger and one is for alighting passengers. So for boarding passengers, passenger will generate in the pedestrian area and then come to the waiting area, and then for alighting passengers will depart at the platform edge and then come to the pedestrian area. So for this, right click, Control right click and drag your mouse to the desired position. Control right click and drag your mouse to the desired position. Similarly, we will create the two routes for each bus stop. So we have created all the necessary arrangement for our transit routes. Now we will run the simulation. And the simulation looks fine. You can move it to 3D mode. The transits are stopping at their bus stops. When there is passengers available for boarding and alighting, then the transit stops at the bus stop. If there is no passenger to board or alight, then the bus doesn't stop at the bus stop. So here the transit line will generate one transit at every 150 seconds. And you can see the on-site bus stop is creating some problem for the vehicles behind it, since they have to wait for the bus to move from the road. Now we will record the LOS and vehicle delay results. For this, go to evaluation and then configuration. We will choose bus and car from the vehicle classes since we need to record the delay and LOS of transit also. An interval for this time I'm choosing 3600 seconds and press OK. We will choose our desired attributes from the attribute selection list. So we will choose the level of service of bus and the average delay of bus. And we need the direction, the movement too, but we have already this in our list. So press OK. Now we can run the simulation. We will run it in quick mode so that we get our results quickly. So the simulation will stop at 3600 seconds because it is set at that time. Now we will copy the results in an Excel. So here you can see the vehicle delay for total movement is 30.35 and LOS is C. The vehicle delay is in seconds. Now we will create an alternate scenario, which is queue jump plan. So for this, select links from network objects, add one lane link, right click and add new link, press continue. Adjust the links with the desired background. So control right click to generate points. So this queue jump lane will start at the beginning of at the end of the longest queue and end at the far side bus stop of that intersection. So we will drag and continue the link up to the far side bus stop and then make the bus stop on the queue jump lane. So if you want to move the pedestrian areas, so control and select all those areas and move. And to add these two links, we have to create connectors. So now the bus stop and platform edges are on the queue jump lane. Queue jump lane helps in passing the transit, the queues formed in an intersection. We have to adjust the edges so that there is some overlap with the pedestrian areas. If there is no overlap, the pedestrian route doesn't work. Now we have to resolve the conflict areas. We will give priority to the through movement that is already on the street, and the transit will wait for a gap in the main street. So the through movement is green and the transit movement is red. Now we will adjust the public transport line. So we will display the lists and select the line and press Ctrl key and right click on the route and drag it to the queue jump lane so that the transit passes through this lane. And we also have to make the transit stop active, so double clicking and checking the active box. The alighting percentage says what percentage of pedestrian alights in this bus stop. Since here is 100%, so 100% of the passenger alights in this bus stop. You can also change the alighting percentages according to your desire. So we can see it doesn't go through the first stop bay, so we will create another point at this bus stop, and it also changed the queue jump lane, so we have to create another point again. So now there is 2 points on the stop bay and the queue jump lane, and we have to make the stops active. If it's inactive, then the bus line won't operate in that stop. We will add the same signal head as to its adjacent approach. So we will add the signal group 2 signal head. So for this you can press Ctrl key and left click and drag it to create a copy of your signal head. So transit here will face the same signal group as its adjacent approach. If you want to delete a signal head, you can just press and hold it and move it to the outside of the links. Now if you run the simulation, the result lists will show the node results with level of service and average vehicle delay values. So we can see the transit has taken the queue jump lane to help pass the queues formed at the intersection. So that is how transit is modeled in VISSIM. Now you can compare the normal result and these alternative results. So let's compare the results of the alternative. So we will go to evaluation, configuration, bus and car is already chosen and the interval is 3600 seconds. We don't need the links result now and press OK. and from the attribute selection we will keep our required attributes and move the other attributes to the left side. If we run it in the quick mode, and since it is set to simulation second 3600 seconds, so it will stop at 3600 seconds. Now we will copy the results and paste it in an Excel to compare our result. Here the numbers in the bracket represents vehicle class, 10 for cars and 30 for transit. So we can see LOSC for buses and LOSC is also for cars, and vehicle delay for transit is 28.16. Previously it was 30.35 seconds, but introducing a QJL reduced the transit delay up to 28.16. So that's all for this tutorial. Thank you for watching.